Okay, so I'm sharing screen here. But to see this, right? So we did exponentiation, exponents yesterday, and then a closely related topic is logarithms. So again, you would have done logarithms in some form or shape before, but we'll get started from the basics, right? So you can think of, you're able to see my screen, right? Can someone confirm? Moksh, yeah, okay, good. Okay, so you can think of logarithm as a reverse process of exponentiation, not reverse. It's just like you can write any problem. You can write 7 plus 3 is 10. You can also write 10 minus 3 is 7, right? So addition and subtraction are sort of related. Similarly, 7 into 3 equal to 21. And then you can write 21 by 3 is 7. So multiplication and division are related, right? Same thing for exponentiation and logarithm. So 2 power 5 is 32. Now I can write this same thing in a different way, and that is using logarithm. So the way I write it is log, okay? And then try to get into the habit of calling what is the final result first, right? So 32 is the number that you're trying to reach using a base of 2. So sometimes students say this log 2, 32, right? Don't do that. Go this way, log of 32 to the base 2, right? Log of 32, even though it's a mouthful, try to get used to saying it that way. So it'll serve you well in the long run. So log 32 to the base 2, right, is what? Is 5. So log 32 to the base 2 is such a number to which this base, so base is written slightly below the level at which the log is. Log and the resulting value are written in the same level. So base alone is slightly to the bottom, right? So log 32 to the base 2 is 5. So essentially another way of conveying that 2 to the fifth power is 32. Okay, so log 1 by 8, for example, to the base half would be 3, because half power 3, right? Half power 3 is 8. Half power 3 is 1/8, sorry. Okay, so what are some of the restrictions for logs? You cannot have log of a negative number, right? So even though, let's say minus half power 3 is minus 1/8. So this is fine. But what is not fine is saying log minus 1/8 to the base minus 1 by 2 is 3. So this is wrong. Okay, so it is possible in complex numbers you can do that, but for now we'll go with the concept that this is wrong. So this is equivalent to saying I can say 7 into 0 is 0, but I cannot say 0 by 0 is 7, something like that, right? So multiplication is allowed, but the corresponding division is not allowed, right? Again, this is not a very direct example, but roughly you can think of it that way. One operation is allowed. The exponentiation is very much allowed. Minus half power 3 is minus 1/8. But the logarithm of a negative number is not allowed. So logarithm not only of a negative number, the base and the actual number both need to be positive. For example, a question might arise. So minus 3 square is 9. So I'm giving log of 9 only, right? 9 is still positive. Can I say to the base minus 3 is 2? Even this is not allowed, right? Both the logarithm of whatever you're calculating as well as the base, both need to be positive. Okay, both need to be positive, strictly positive, not even 0, right? I said cannot be negative. It cannot even be 0. So log of 0 to any base is not defined. Log of any number x to the base 0 is also not defined. Okay, so all of these are not defined. Further, one other thing is not defined. Okay, what is that? Log to the base 1. Okay, so why is this not defined? So 1 power anything, 1 power 17 is 1. Okay, so if I say log 1 to the base 1, should I say 17 or should I say 32? Log 1 power 32 is also 1, right? So what should I say? So because I cannot say anything, therefore log 1 to the base 1 is not defined. And what if it's log of not 1 to the base 1? Suppose it is log of 4 to the base 1. I can never reach 4 by putting 1 power anything. So log 1 to the base 1, it's not defined because it can take literally any value. And log of 4 to the base 1 is not defined because no value will work, either 0 solutions or infinite solutions. Log 1 to the 1. Yes, go ahead, Moksh.
Would log 4 to the base 1 be defined on the complex plane?
Yeah. So all of these can be defined, some of them in complex numbers. But again, let's not confuse that. Even with complex numbers, for IB, you don't require this, right? But know that it's possible. Correct. Right? So log 4 to the base 1 is not defined because it has 0 solutions. Log 1 to the base 1 is not defined because seemingly it has infinite solutions. Okay. But however, what is allowed is log 1 to the base 7. That we know is 0. Right? Because 7 power 0 is 1. So log 1 to the any base, when I say any base that's allowed. So we already have agreed that the base has to be positive and the number also has to be positive. With those two constraints, the base can be any positive number other than 1. Whereas the actual number for which you're trying to calculate the logarithm can be any number, literally, right? So the first part is already covered. Because you're ensuring that the base is not 1, automatically the logarithm of 1 to the base 1 is also not going to be covered in that, right? So we can say, in other words, if I have log A to the base B, just to summarize, so what is allowed? A has to be greater than 0, B has to be greater than 0, and B should not be equal to 1. This covers everything, right? I don't have to explicitly put A log 1 to the base 1 is not allowed, because that will anyway get covered as part of restricting B to be 1, right? I don't have to say A not equal to 1 if B equal to 1. So hope that subtle point is clear, right? So A greater than 0, B greater than 0, but B should not be equal to 1. Further, the value that results in this C, let's say this is C. It'll turn out that the C can be literally any number. It can be range from minus infinity to plus infinity. It can be a negative number. How can it be a negative number? So 7 power minus 2 is 1 by 49. We have seen that yesterday, right? So if I have to write that as a logarithm, then log of 1 by 49 to the base 7 will be minus 2, right? So it can be a negative number. It can also be a fraction. So let me just break the monotony by changing colors here. Okay, it can also be a fraction. So we know 8 power 1/3 is 2. So if I have to write it as the logarithm, then log 2 to the base 8 is 1/3. And it can be a combination of negative and a fraction, right? It can be negative, it can be fractional. So it can be a combination of both also. For example, let's say 25 power minus half is what? 1 by 25 power half, which is 1 by square root of 25, which is 1 by 5. So if I write it as logarithm, then log of 1 by 5 to the base 25 is minus half. So it's negative as well as fractional. So in a sense, it can be a negative number, it can be a fraction, it can be 0. We saw it could be 0, right? Log 1 to the base 23 is 0, right? So answer can be 0. It can be a positive number to whatever extent, all the way till infinity. So if I have a log of a zillion, right? Or whatever, 10 power, in fact, log of 10 power 25, let's say, to the base 10, by definition would be 25, right? Because 10 power 25 is the value you need to reach to what base? To the base 10. So by definition, the answer has to be 25, right? And you can crank up this number 25 to anything, and therefore this 25 can go all the way till infinity. Okay. Yeah. Now let's. So far so good. Everyone with me so far? Did Sarah join? Sarah, are you there? Not able to see everyone in class in this view. Probably shouldn't join. Okay, fine. But Thais, you're able to hear me well, right? Today, better than yesterday. Or even yesterday, you could hear me, only I could not hear you. Fine. Okay, cool. Okay, so let's go through some of the main, Dave, all okay? Any doubts so far? Okay, let's go through some of the main properties of logarithm, right? So log of AB is log A plus log B. Okay, by the way, you'll see this. If I don't put any base, it means the property is true for any base, literally. I don't have to put a base. So when I don't mention any base, it means it's the same base throughout the problem. But I'm not mentioning that. So with C here, it's constantly the same C, same C. Okay, so sometimes I will put, if I don't put, it means for the entire statement, it's true for any base. Okay, so log AB is log A plus log B. And this is fairly easy to understand, right? So for now, let's pretend the base is C. So let's say C power M is A and C power N is B. Okay, so this means log A to the base C is M. That's what this means, right? Because C power M is this. And this is N. So the right-hand side is M plus N. So what is the left-hand side? AB. What is AB? AB is the product of C power M and C power N, which is C power M plus N. And if I ask what is log of C power M plus N to the base C, let me just put C so that it's easy for everyone to follow. Okay, then we can see that log of C power M plus N to the base C is indeed M plus N. So it is true that M plus N is equal to M plus N. Okay, so likewise, the division rule analogously would be log of A by B, log of A by B, okay, will be log A minus log B. Again, you can try proving it yourself using similar logic. A is C power M, B is C power N. If I do the subtraction here, it's M minus N. And here it's C power M by C power N. So C power M minus N is what A by B would be. And when you take to the base C, the result will be M minus N. So you'll get M minus N equal to M minus N. I just went over it quickly, but you can try it yourself. Very similar. Okay. Now the third property is, suppose I have log of A power K, right? Log of A power K. It's important to put the brackets, because if I just say log, if I write it like this, there's scope for confusion. So some people might interpret it as log A whole power K, and some people might interpret it as log of A power K, right? So just to avoid that, always put brackets. So here I'm talking about log of A power K, right? So these two are not same, right? These two are not same. And therefore, you can have confusion. So always put brackets. So log of A power K is K times log A. So where is this coming from? It's coming from, you can think of this as log of A into A. So this is log of A into A into A into A, like K times, right? K times. K times. Now by the product rule, we know we can split. If it's log of AB, it's log A plus log B. You can do that, like you can think of it as the first multiplication being A multiplied by the rest. And then you can split it as log A plus the rest. And then you can apply that same thing again. So we can go to this A and say, this is this A times the rest. So times the rest, times the rest. So it comes to be log A plus log A plus log A plus log A K times. Hence it's K times log A. Okay, all of you okay on this? Thais, you're okay? Yeah. Okay. Now, log of A to the base B. Okay, so this can be written as log A to some base C upon log A to the same base C. So this is extremely important. This is called the change of base rule. So these three are very basic. The first three that we discussed are fairly basic, right? And not that the fourth one is any hard, but it's an important one, right? So you can get some difficult problems based on change of base rule. So it's quite important. So what is this change of base telling? So as the name suggests, change of base, right? So for example, suppose someone asks log of 64 to the base, I don't know, 32, right? So I cannot immediately tell an answer, right? But you know that it should be a reasonable number, because by reasonable, I mean it should be a fairly intuitive number, because both 64 and 32 are in the 2 power family. So realizing that both are in the 2 power family, I can say this is same as log 64 to the base 2 upon log 32 to the base 2, right? And therefore, I know the value for this is 6 I know the value for this is 5, and therefore it's 6 by 5. Right? And you don't have to necessarily say 2. For example, this is very much equivalent to log of 64 to the base, I don't know, 13 upon log 32 to the base 13. This is also true, but it's not helping me. I don't know log 64 to the base 13, nor do I know log 32 to the base 13. But the fact remains that this is also same. This is very much same as this is. But I want to choose 2 because that will benefit me. Because log 64 to the base 2 is something I know. Log 32 to the base 2 is also something I know. I get to choose what the changed base should be to suit me, to help me. Okay, so that's change of base rule. Now, as a special case of change of base, so a special case of change of base comes by choose C to be equal to A. If you do that, then you'll see an important result. So you'll see log A to the base B is log A to the base A, which is just 1. The numerator becomes C is just 1, let's say. C is just A, let's say. Log A to the base A is 1. Log of 13 to the base 13 is 1. Log of 17 to the base 17 is 1, right? So log A to base A is 1. So 1 upon log B to the base A, right? So log A to the base B and log B to the base A are reciprocals of each other. So which is why, if you know log 8 to the base 2 is 3, we could see that log 2 to the base 8 is 1 by 3, right? So this is just a special case of change of base where the choice of C happens to be the same as A, in which case it turns out that log A to the base B and log B to the base A are reciprocals of each other. Okay. And then one other thing. So whenever people use logs with numerical numbers, numerical is number, right? So when people say log 1000, we spontaneously say it's 10. We spontaneously say it's 3. The reason people do that is because by default, the base is assumed to be 10, right? So the default base is 10. Okay, so just like when you say square root of, I don't know, 49, you immediately say 7, even though someone does not specify it as second root of 49, or is it the fifth root of 49? They didn't tell you that, right? But you assume that by default, it's this. So everything has a default. Like that, I didn't say it's log 1000 to the base 63 or log 1000 to the base 7 or log 1000 to the base 10, but you assumed it's log to the base 10. So default base is 10, but generally, problems are explicit, but if something is not given, just assume the base is 10. So log 1000 to the base 10 or log 1000 rather is just 3. Similarly, you will see the letters LN, right? It's to be pronounced lawn, as in your lawn, right? Your garden lawn, right? It's pronounced that way, but it's written LN. So it's called the natural logarithm. So this means log to the base E, right? Log to the base E. So if I have, right, ln x is log x to the base E, and E is just a mathematical constant like pi. So pi was approximately it always is. So 3.14. So E is approximately 2.71. And we saw an introduction to E in the context of the geometric progression or the compound interest. So the definition of E was, if you let a small number h tend to 0, and you take 1 plus h and raise it to the power 1 by h, right? So in that limit, h tends to 0. This approaches this value, 2.71, right? So example that we saw was 1.01, in which h was 1 by 100.01. So reciprocal of that was 100. So you did it in your calculator and saw that your answer was close to 2.71, right? So the closer this number gets to 0, the better your approximation will be. And it'll finally reach this mathematical constant called E, right? Which approximately is 2.71. Okay, all right. So by the way, just a small side note. So pi, an easy approximation that we all studied so far is 22 by 7. A much better approximation is just write 113355, right? And then put a division sign here. So 355 by 113, you can try it on your calculator later, is a much better approximation for pi, right? 22 by 7 is a
355. You
355. Yeah, 350. I wrote it here correctly, but here I wrote it wrong. So 113355 and then put a division sign halfway. So 355 by 113, right? So pi is, I remember a few decimals. I know a lot of people try to 1.415.92654, something like this, right? I think this latter 355 by 113 covers it all the way till somewhere here, right? So it's a much better approximation. Just a side note, you don't necessarily need for your IB stuff, but just saying. Okay, so where were we? We were in the natural logarithm, right? ln. So ln of e cubed is 3, right? Just like log of 100 was 2. Okay, because ln is to base 3. In some later textbooks, you will see that the default for logarithm itself is e, right? And like as you go to college and all, by definition, log without any base is e. But for now, it's going to be 10. Okay, and just like ln, the log to the base 10 is also written in short form with just 2 letters, lg instead of log. I don't know, there's not too much to gain, right? Just a literally one more letter, but people have gotten more and more lazy over the years. They just put lg, right? lg of 100 is also same as log of 100. Okay, now one important thing, one last thing is, what was I going to say? Yeah, right. Let me just go up here. Okay, so log of okay, so 10 power log x is back to x. Okay, so what does this mean? So if someone says 10 power log x, it's just a complicated way of saying just x itself. So why is that? So why is this true? Why? Okay, so let's say log x to the base 10, right? Log, I'm not putting a base, right? So in fact, let me put a base so that's clear. So let's say log x to the base 10 is some value, let's say p, right? So how does this translate in terms of powers? 10 power p is x. That's what it means, right? These two are equivalent statements. Log x to the base 10 is p, means 10 power p is x. Now put back your p from the first step. So it's 10 power, instead of p, put what was there in the first step, which is log x to the base 10 is x. So 10 power log x to the base 10 is just back to x. Or more generally, if I have any base p, if I have p power log x to the same base p, the answer is back to x. Because by definition, log x to the base p is such a number to which b must be raised to reach x, right? What is the definition of the box I've circled? It's such a number to which b must be raised to reach x. And that's exactly what you're doing. You're taking b and raising it to that such a number. And that obviously no surprise, the answer should be x. Does this make sense, guys? Moksha, share with me completely? Okay.
Yes.
Hello, Keshav, all good?
Yeah.
Yeah, Keshav, can you lower your camera because I'm not able to see your full face? Right, same with Dave as well. Yeah, for example, Moksha is sitting perfect. Thais also, you could, I want to see your full frontal face, guys. Yeah, no, Moksha, you're good. You're fine. Yeah. Okay. All right, let's jump into problems. Let's do a few problems for practice. Yeah, keep your calculator handy, but you don't have to use it just yet because some of these initial problems are non-calculator. Okay, I'll just paste this entire section, but I'm not going to ask you to do all the problems, right? So I'll just randomly call out a few questions. Can we do question E? Can you tell me the answer for question E? Yeah, you don't have to raise hands, guys. I'll make sure that everyone gets an equal chance. So it's okay. without calculator. Okay, Moksh, since you raised, fine, take it. What's the answer?
2 raised to 1.4.
2 raised to 1.4.
1 upon 4. 1 upon 4. 2 raised
Two-
to raised to 0.25.
2 raised to 1 upon 4. Yeah. Yeah. So 2 raised to 1 upon 4 whole power 4. So we can check, right? So if it indeed it's that, then 2 power 1 by 4 whole power 4 is indeed 2. Yeah. Right. So the way to do this is x power 4 is 2. That's what this means, right? So the meaning of this is x power 4 is 2. To get x, I'll raise both sides to the power 1/4. Right? So the left-hand side just becomes x. So x is just 2 power 1/4. Right? Which is square root of 2. If you want to write it this way. So square root of 2 is called square root. Okay. All right. Dev, can you take this one?
4x is equal to 4.
X equal to 4, right? Fairly straightforward. X cannot be -4, even though -4 power 2 is also 16. I cannot say -4 as an answer here. Okay. Thais, can you do the I? Log 1/3 to the base x equal to 3. You don't have to give a numerical answer. You can give, like he said, 2 power 1/4. Right? In this case, it turned out to be a round number 4. Right? You can give your answer as something like that. Oh, Thais, you have your the audio trouble, right? You won't be able to speak, or will you be able to? Try. If it's bad, I'll pass it on. Very, very faintly. Go ahead. Louder.
3. I don't know if I'm right.
That's fine.
Uh,
Try.
So it's equal to x power 1/3 equals to 3. So I should raise 3 to the power of 1/3 2. Can you hear me?
I can hear you, but what you stated first is wrong. You said x power 1/3 equal to 3. No, that's not what the statement is saying. So this statement is not saying that. The statement is saying x power 3 is 1/3. So I know x is here and 1/3 is here. So it's tempting to say x power 1/3. No, it's x power 3 results in the value 1/3. Just like in this question, right? So he said x power 2 results in the value 16. So hence x equal to 4. Right? So similarly, back to this question. So it's x power 3 equal to 1/3, right? You're with me, Thais? Right? And after this step, to reach x, you raise both sides to the power 1/3 and say, therefore, the answer is x equal to cube root of 1/3. So it's 1/3 power 1/3, or you can write it as cube root of 1/3, which is written this way. Okay. All right. Keshav, can we do question J?
2 to the power 4 is 16, so x is 21.
X is 21, right? So fairly straightforward. 2 power 4 is 16, x is 21. Okay, let's move on. Okay, so have your calculators handy, guys, for this next one. Okay. Okay, all right. Dave, can we do yeah, this one, F. What is the value for X?
So I can do like, for example, 1 upon x is equal to e, but I don't know.
Yeah, using Using calculator, yeah. So 1 upon x is e, therefore x is 1 upon e. Yeah.
Okay. Yeah.
Yeah, as simple as that. So x power minus 1 is e. That's the first step, which you realize is 1 upon x. And therefore reciprocate, x is e power minus 1 or 1 upon e, right? So it's fine. You don't have to look up calculator. It's okay. 4 minus 2, actually fairly straightforward, right? All of them are. Should I maybe I'll just try one more. Okay. All right, Moksh, can you tell me the answer for this one? Log of x minus 2 to the base e equal to 1.
Log of x minus 2 to the base equals 1. It means e raised to 1 equals x minus 2. So just x minus 2 equals e. So x equals to e plus 2 or 4.718.
Yeah, approximately 4.718. Perfect. Okay. All right, let's move on. Okay, without using calculator. Okay, Keshav, can you do me this question C without using calculator? Guys?
2, right? Because log 5, that's the log. 25.
Exactly. Log of this 2 times 12.5, which is log 25 to the base 2, which is to the base 5, I'm sorry. Therefore, it's 2. Okay. Thais, question D.
I'm sorry, I didn't hear the answer for the C. Question
For the
C.
C, so the C part, the answer is 2. So it's log of 2 times 12.5, which is log 25 to the base 5. Because log A plus log B is log AB. Okay. So Thais, can you take part D?
Okay.
Yeah, we did the subtraction rule, right? Log A minus log B is log of A by B, right? We can apply that here.
Sorry, there's someone in my room.
Okay, no problem. Yeah, okay, so log A minus log B, which is log of A by B, which is log of 18 by 6, which is log 3 to the base 3, and therefore the answer is 1. All right, so answer is 1. Okay. Let's see. Can we do Moksh, write down an expression for log A in terms of log B and log C for F.
Okay. Let's try it by taking the log of both sides. A log A equals log of b squared over root c.
Yep.
And then we know log of b squared over root c is the same as log of b squared minus log of root c.
Yep.
Then we can make so that log A is equals to 2 log B minus a log C upon 2. Because like taking the exponent outside of the log.
Yeah, but only one word of caution. Don't say log C upon 2, because when you say log C
Yeah,
upon 2,
I got it,
it
right.
could be, people could interpret it this
Log
way.
of C whole upon 2.
Yeah, either, so write it log C whole upon 2 this way, or even to avoid that controversy, put the half before. So
Yeah,
just say
1
half
upon 2
times
log
log
C.
C.
Yeah.
Half times log C. So even this is fine, but right, just be careful of these small
Yeah.
things, okay? Okay, so this way you're safe. Half times log C, right? Which is same as log C whole by 2. So log C whole by 2 is same as half times log C, but it is not the same as log of C by 2. We all know this. Okay. Okay. Keshav, can we express each of these following as an equation that does not involve logarithm? No. Does not involve logarithm. Okay, can we do the F part? So you have to write it out in such a way that there's no logarithm at all.
Okay. So log, the first part is log 2 to the log x plus 1 to the power of 3 to the base 2 is equal to log 2 to the power of y over 2. So that means x plus 1 whole cube is y over 2.
Exactly. Right. So first write it out such that both have the same log base, and then you can remove the log to the base 2 completely and write it this way. Okay. Dave, can you take this one? Part D.
2 raised to y plus 1 is equal to x.
That's it. No more x. That's it. You're done.
Yeah, okay.
Right? Why are you prompting yourself for a next
No,
step?
I
That's
thought
it.
maybe I could simplify it further, but
Yeah.
obviously not.
Yeah. So nothing more. You've done your bit, right? It should not involve logarithm, and you've reached. That's it. Right?
Okay,
That's
yeah.
Okay. Let's do some solving questions. Let's see. Can we do, in fact, all of you work it out. Part D, question D. Solve for x. Okay, yeah, Moksh, go ahead. What's your answer?
I got 1.5. Should I explain?
X equal to 3/2 is your answer?
Yeah.
1.5. Okay, let's quickly do it, guys. So the left-hand side is log of x plus 3 upon x by log A minus log B rule. The right-hand side is log of x into 2 to the base, same base 10. And therefore, I can remove the log completely. The base is same. So it simplifies to x plus 3 equal to 2x square. So I can write it as a quadratic 2x square minus x minus 3 equal to 0.
Yes, 1.4.
Sorry, did I do a mistake?
No, it's just 1.4.
1.4?
1.5.
1.5. Okay, I'm just trying to solve it step by step. So minus b plus or minus root of b square minus 4ac whole upon 2a. Right? I could have factorized also, but I found this is easier. So 1 plus or minus 5 divided by 2, which gives two answers, 3 and minus 2. But we must only take 3 and not minus 2. Not because minus 2 is a negative number. It's not like negative numbers are always forbidden. Put that negative and see in the specific problem if there's a violation. So yes, minus 2, if you put here, there's no violation. It's minus 2 plus 3 is log 1 to the base 10. Still a valid number. But if I put here, it's a problem. Minus 2 to the base 10 is a problem, right? And therefore, we avoid minus 2. So same with positive number also. Just because your answer is a positive number, just don't go automatically with it, saying it's good, right? Positive or negative, whatever it is, to eliminate or check the validity, put back that answer in the original question and then test it out yourself. There could be negative answers which are valid. There could be positive answers which are not valid. So just don't go just on the surface of it and say negative answer, therefore not possible. Okay, all right. Thais, can you take this one?
One thing, one question.
Yes.
I solved the quadratic by factorization.
Sorry, one mistake. I got 3. You got 3/2, you said.
Yeah, I solved the quadratic by factorization and I got the factors as 2x plus 3x
no.
minus 1.
It would be
No, you're right. You're right. I made a mistake. Minus
should-
b plus or minus root of b square whole upon 2a, right? So 2a is 4. So it's 3/2 and minus 1 indeed. So it's 3/2 and minus 1, but minus 1 is not allowed. Therefore, it's 3/2 indeed. While writing the roots, I made a mistake here, right? Divide by 4, not divide by 2. Okay, all of you comfortable with the basic quadratic roots, right? Thais, minus b plus or minus square root of b square minus 4ac whole upon 2a.
I know it, but I need some time to like use
Practice
it
it.
properly.
Yeah. So definitely
practice
practice because a quadratic is all pervasive. So anyway, I'll just write it out explicitly for everyone. So it's minus b plus or minus root d whole upon 2a, right? Where this d is a very important value. It's b square minus 4ac because that will determine, I will do obviously quadratic in a lot more detail. Next week we'll do quadratics, but b square minus 4ac is a very key value for solving all quadratic problems. Okay. All right. All of you do question I. Let's discuss question I after you're done. Okay, Dave, go ahead. What do you have? Yeah,
I got 4.
4. Okay, let's check. So x plus 5 times x. So it's log of x plus 5 times x, right? To the base 6 is 2. So I have x square plus 5x equal to 36. Right? So which can be simplified as x plus 9 times x minus 4 equal to 0. Therefore, x equal to 4 or x equal to minus 9, x equal to minus 9, you can immediately see has violation. You get negative numbers. Log of negative number not valid. Therefore, x has to be 4. Okay. All right. Rest are very similar. Let's move on. Simplify. Okay. Let's do more solving questions. Yeah, can we do question F? Okay, sometimes the print is not very clear, but you can deduce, right? It's log of root x to the base 3, right? And this is log x to the base 3, right? Sometimes the base is not substantially down, so it's a little confusing, but I've written it explicitly for you guys. Yeah, without calculator, this one. Okay, Keshav, you have an answer on this one?
Yeah, I got x is equal to 9.
9? Yeah. Okay, let's solve it. So log of, so by the product rule, it's root x, and this is the 3 goes here, right? X cubed. So log of x cubed into root x to the base 3 is 7. Okay, so it's log of x power, this is x power half, this is x power 3, so it's x power 3.5, 3.5 to the base 3 is 7. So x power 3.5 is 3 power 7, right? I can raise both sides to the power 1 by 3.5, 1 by 3.5. Therefore, this becomes 3 square, and that's x, which is 9. Okay, good job. Right, let's do. Can we do part C on this? So the left-hand side is, so if you don't put a bracket, then it should be interpreted as log of x power 4 to the base 4. And right hand side, I'm explicitly putting a bracket, log x to the base 4 to the power 4. Okay, Moksh, I'll give you 20 seconds and then you can call out. Okay, go ahead, Moksh. What do you get?
I'm pretty sure my answer is root 2.
Root 2. Okay. Anyone else with the same answer or a different answer or an additional answer?
I think I made it incorrectly. I'm not sure, but I got x is equal to 1 over 3.
1 over 3 for the part C, right? Okay, let's discuss. So we have log of x power 4. So the left-hand side is 4 times log x to the base 4. On the right-hand side is log x to the base 4 whole power 4. So what I'll do is, I'll say log x to the base 4. I'll call it some number like, I don't know, w or something, right? So 4w equal to w power 4. Okay, so I can write it as w power 4 minus 4w equal to 0, which I can simplify as w times w cubed minus 4 is 0, which means either w is 0 or w cubed is 4, right? Which means w is 4 power 1/3. So the two answers for w are 0 and 4 power 1/3, but w is my own making. I'll have to convert it back to x. So log x to the base 4 is either 0, which means x is 4 power 0, which is 1. That's one answer. Or log x to the base 4 is the other value for w that we got, which is, what is it? 4 power 1/3, right? 4 power 1/3, which means x is 4 power. Am I making mistake, guys? Just check. No, right? 4w equal to w power 4 cubed. X is 4 power 1/3. Now let's check both of these answers. Okay, so first of all, before that, let's check what.
Isn't x?
So I think Keshav's answer is correct.
Sorry,
I think it's 1/3.
am I doing something wrong?
So you took w is 4 raised to 1/3. So log x to the base 4 is 4 raised to 1/3. So you can just see that x is
Yeah, log x to the base 4 is 4 power 1/3. Yeah. So 4 power 1/3, right?
oh yeah. I think that-
It's log x. Oh wait, no.
yeah, it's 4 raised to cube root of 4.
So right. But meanwhile, let's check these answers also that you guys have called out. Suppose it's root 2, then the left hand side is saying log of root 2 power 4 to the base 4, right? What is root 2 power 4? Root 2 power 4 is root 2 power 2 whole
No,
power
it's
2.
It's 4
Which
only.
is-
No? Root 2 power
yeah.
4 is 4.
Root 2 power 4, yeah, it's 4, right? So root 2 whole square, which is 4, right? So 4 power 4, which is 1. Okay, the left hand side is 1. Are we getting same as the right hand side? No, we are not. Log root 2 to the base 4 is, as we just saw, 1/4, right? Log root 2 to the base 4 is 1/4. How did we say that? Because let's say this is m, then root 2 is 4 power m, right? I can write this as 2 power half. I can write this as 2 power 2 whole power m, which means m is 1/4. And is 1/4 power 4? 1/4 power 4 is how much? 1 over 256. Whatever it is, it's not equal to 1. So that way I know that Moksha's answer is wrong. right? I'm just trying to make sure that the answers are right or wrong just by verification, right? And similarly, let's test.
The 1 over
Keshav.
3, I meant to write 4 to the power of 4 to the power 1 over 3, but I did it wrongly.
Okay, that's fine. Okay, but just so that, okay, yeah. So if you put 1 over 3, I don't think we'll even be able to evaluate an easy expression for it. Yes, right. So 1 over 3 is wrong. So he admits it. And even if you put, it becomes a little difficult, right? So if you try to put log of 1/3 power 4 to the base 4, you need a calculator actually to evaluate this, right? So you won't be able to do it. But is this clear? Thais, is this clear how I got W and then hence I got my X as this?
Yeah, it's clear.
It's clear, right? Okay. In fact, there's a last part to the same problem, which is generalize. Yeah. Investigate. Okay. Instead of 4, his n, he wants to generalize. Can we do this? Log of x power n to the base n. What we did was n equal to 4. Now he wants us to generalize. Okay, Keshav, do you have a general expression?
I think I got the answer.
Okay. All right, one of you, Keshav. I called out for Keshav first. Okay, all right, Keshav, go ahead. Do you have an answer?
I just, when you mean generalize, just.
Generalize for a n, right? Instead of specific number like 4.
Oh, so I got n is y to the power of n minus 1. So y,
No.
log,
X equal to. We are solving for x.
yeah. Oh, okay. I think I have to redo it. I think I did something wrong.
Yeah, we are solving for x, right?
Okay, so n is equal to x to something, right?
You should write x equal to in n power something.
Oh,
Assuming n is a number, we did the previous problem, right? We got 4 power something, right? Same thing, we have to get x in terms of n. X as a function of n.
So can I try?
Yeah, go ahead, please. Yeah.
So I got n minus 1 raised to n. So w bracket, so we took w last time, so just took w again. W bracket n minus 1 raised to n is equal to 0.
What is my x? I don't care what w is, because w is something we invented. The problem does not have w. You should call out your final x.
So
N minus 1 raised to n. But I don't think that's
okay, fine. Call out your answer, then we'll discuss. N minus 1 raised to n. Is that what you said? Okay, if that's the case, then the previous problem must have been, you agree the previous problem was n equal to 4. We did not get an answer like 3 power 4, right? In fact, but guessing by the previous answer, we got 4 power 1/3, right? So if I just have to guess based on that, it should be n power 1 by n minus 1, something like this as one of the answers, right? Right? Moksh, is that what you got as one of the answers?
Yeah. I got n raised to 1 upon n minus 1. That would be the answer to the log x base n. We'd have to do n raised to n minus 1.
Yeah.
And that's equals to x. And you're doing the above power first, not the lower power.
Yeah. So it's this, right? n power 1 by n minus 1. Because even here, if you don't put the brackets, it is little confusing, because people could think this is n power n whole power 1 by n minus 1. So for example, let's take some numerical example, right? So suppose it's 2 power 3 whole power 5. Then one person could interpret it as 2 power 3 whole power 5, which is 2 power 15. Another person could interpret it as 2 power 3 power 5, which is a much bigger number, which is 2 power 243, right? Always, when you are writing your answer, put brackets, right? So what I meant was, based on the previous problem that we did for a specific value for 4, it was 4 power 1/3. So it should be n power 1 by n minus 1, based on the guess, the pattern recognition. But let's actually get that. And obviously the other answer will be 1, right? We got 1 was an answer because left hand side also becomes 0, right hand side also becomes 0.
So isn't it convention that whenever you're doing multiple powers of powers, that you always consider the upmost first?
Correct.
You
Correct.
always need to specify.
That's right. Yeah. Technically, you don't need to. So by the BODMAS rule itself, this means, so what he's saying is the default way of assuming this is this, right? And not this, right? So even if I don't put brackets, I should technically be fine. So I should be able to write it as 4 power 1/3 and let the person figure out that the power, which is 4 power 1/3, gets priority first. You start approaching it from here, right? So if I say 2 power 2 power 2 power 2, right? So first I'll do this 2 power 2, which is 2 power, which is 4, sorry. And then I'll do 2 power 4, which is 16. And I'll say the value is 2 power 16, right? Okay, anyway, so back to this question again. Should we do it or we're okay? All right, let's do it quickly, right? Yeah, so I'll write it as n times log x to the base n equal to log x to the base n whole power n. And let me treat log x to the base n as whatever w, whatever we said, w, right? W, right? So I have n times w equal to w power n. So I can write this as w power n minus n times w equal to 0, which means I can take w outside, w power n minus 1 minus n equal to 0. So I'll continue here. Therefore, either w is 0 or w is n power 1 by n minus 1, right? From here. And therefore, this would imply that my x is what? N power w. So it's n power 0, which is 1. Or my x is n power w, which is n power 1 by n minus 1. Right? Which was what our intuitive answer was. Okay, all right. Following. I'm just trying to see if there's any other interesting questions we should do. Yeah, let's do this. And then we'll jump to the next topic. Okay, can we do question E? If you have not approached problems like this, one hint would be let 4 power x equal to u or w, y, whatever you want to call it. So because 4 power 2x will become y square, and then it becomes a simple quadratic. Okay, so just to write the hint in case you're not aware. Let 4 power x be equal to u. Okay. Moksh, what is your answer?
So if we use your trick that you suggested, we get the quadratic equation.
Yeah.
12 times y squared minus 32y.
Call it your final answer, then we'll discuss.
Okay, hang on. I got the answer as log of 2.5 base 4 and log 1/6 base 4.
All right. I prefer simple fractions. So log of 5/2, and in this case, log of 8/5. Is it log of 5/2?
No, so I said 1/6, 1/6, 1/6.
Oh, 1/6. Okay. Okay. So log of 1/6 and log of 5/2. The base 4.
Yeah, I got
Okay.
the same answers.
All right, good. Hopefully they're consistent answers. They must be right. Okay, so let's see. So if I say 4 power x is, so this is 3 times 4 power 2x times 4, right? Minus 2 times 4 power x times 4 square plus 5 equal to 0. So this is 12 times 4 power x whole square, which is u square, minus 32. 2 into 4 square is 32 plus 5 equal to 0. So again, I can factorize, or so 12 times 5 is 60. So I can factorize this as 30 and 2, 30u and 2u. Okay, so I can take 6u common outside, 2u minus 5 minus 1 into 2u minus 5 equal to 0. So indeed 6u is, so indeed u is 1/6 or u is 5/2, which would imply in the next step that x is, so what is u? U is this, right? U is 4 power
U is
x.
4:x.
Yeah. So if I have to convert this in terms of, if I have to write it as x equal to something, x equal to log of u to the base 4. So indeed it's log of 1/6 to the base 4 or log of 5/2 to the base 4. Yeah, well done. Okay, can we all do problem J? And then we'll switch gears to next topic. Log x to the base 2, that one, plus log 2 to the base x.
So I'm not sure if it has an answer.
Okay. All right. Anyone else? Dave, what do you get? Keshav,
Yeah, I'm
Thais?
I'm getting
So at this point, I'm at log of 2 to the base of x is equal to log of 2 over x to the base of 2. Because I made 2 to log of, oh, I made a mistake. I'm
I'm
sorry.
getting log 2 to the base of x is equal to log 4 to the base of x or something.
Yeah.
Okay.
So
Okay,
what,
all right.
what I did is I just saw log 2 to base x the same as 1 upon log x to base 2. And then if you take log x as base 2 as u, you get u plus 1 upon u equals 2. If you solve that, the only answer for u is 1. And you can't have 1 as an answer to the right logarithm and left logarithm.
Okay, you're almost right, but you messed up in the last step. Yeah, so log x to the base 2, if we consider that as u, then log 2 to the base x is just 1 by u, by the change of base rule.
Yeah,
So,
I made a silly mistake. So
yeah, so u square I can multiply by u and then get the 2 to the side. So which means u minus 1 equal to 0, which means u equal to 1. But what is my u? My u is my log x to the base 2. So this can very well be, right? So which is 2 power 1, which is 2. So the only answer for x is 2. And we can just check log 2 to the base 2 is 1. Log 2 to the base 2 is 1. 1 plus 1 is indeed 2.
You can also take log x base 2 to the other side, right? And then do
Yes.
log.
Yeah. Go ahead, please. Describe what you did.
So I did 2 minus log x base 2 is equal to log 2 base x. So then I did
2 minus log x to the base 2 equal to log 2 to the base x, like this.
yeah. And
Okay.
since 2 is log 4 base 2, I got log 4 base 2 over log x base 2 is equal to log 2 base x. And since you can just change the bases when you're dividing, so I just did log 4 base x divided by log x base x is equal to log 2 base x. And then
Okay. So sorry, one sec. I followed you till here, right? So log of 4 by x equal to the base 2 is log of 2 to the base x. And then what did you do after this?
I did wait, I think oh yeah, I think I made a mistake, but I still got it's not possible. So
Okay. Let's continue.
It's a very simple. You can just see that if log 2 base x is equals to 1, you can just do x raised to 1.
Yeah. So, okay, just to continue what he did, it's still possible to finish it off from here. So I will say this is 1 upon log x to the base 2 equal to log 4 by x to the base 2, right? So if I multiply now, I get log of 4 by x
yeah, this is what
times
my
x
handwriting was messy, so I didn't
to the
understand.
base 2 equal to 1. But the problem is you'll get equal to 1, right? 4 by x. Yeah, no, I made a mistake. Log of 4 by x
Yeah, so you get log.
times, yeah,
Yeah. So you get
right, so
2 equal to 1 or something like that.
yeah, exactly. But to solve this further, you need to assume log x to the base 2 is some number u and then go with it, right? Then you'll get 4 minus u times u equal to 1 probably. Am I right? I'm just trying to see, not 4 minus u, 2 minus u. Okay, so if again, it'll lead to the same thing, but I'm just saying you can still finish it off from here. So you can just say this is log 4 minus log x, log 4 to the base 2 minus log x to the base 2 times log x to the base 2 equal to 1. And if you say log x to the base 2 is u, then you have 2 minus u times u equal to 1, which gives you back the same quadratic, but in a long way. You didn't have to do all this. You can straight away start with log x to the base 2 is u. But nothing wrong in what you did, Keshav. We can just finish it up though. Okay, makes sense. Cool. Thais, all good? Dave, all good?
Yeah, I got it. I solved it with using u finally. Wow.
Perfect. All right, cool. Okay, let's switch gears to the next topic, which is binomial. So I wanted to introduce binomial. Okay, so we know that x plus y is just x plus y, nothing there. X plus y whole square is x square plus 2xy plus y square. So if I write the coefficients for this, it's 1 and 1. Here it's 1, 2, 1, right? And if I have x plus y whole cubed, it's x cubed plus 3x square y. So first of all, I'll write this is binomial. Binomial theorem, binomial expansion, all of them are very related through 3xy square plus y cubed. So you see the power of x keeps decreasing, power of y keeps increasing, right? So this is x plus y whole cubed. So I can fit it in here like this, 1, 3, 3, 1. So this is the Fibonacci, I think double C, right?
Pascal's triangle.
Sorry, Pascal's triangle. What am I talking? Pascal's triangle, not Fibonacci triangle, Pascal's triangle. Right? So you might not have heard the name, or you might have heard the name, but you can see the pattern, right? So you keep adding 1 and 2. You add 1 and 2, you put the number here, 3. You add 2 and 1, you get the number here. And then similarly by the pattern, 1 plus 3 is 4. If we put 4 here, 3 plus 3 is 6, 3 plus 1 is 4, and put 1 at the far end. So that is indeed the expansion of, one sec, let me just move this here. But that's indeed the expansion of x plus y whole power 4. So it's 4x cubed y plus 6x square y square plus 4xy cubed plus y power 4. Okay, and then we can keep doing this, but you can guess the next one is 1, 5, 4 plus 6 is 10, 6 plus 4 is 10, 4 plus 1 is 5. So this will be the coefficient of x plus y whole power 5. Okay, but where are we getting, how can we generalize these numbers? And why are we getting these numbers? One sec, let me just align the Zoom window. It's not very clear. Okay, right. So suppose, let's take x plus y whole power. Actually, before that, let's start to do some basics of choosing, right? Permutation and combination, just very basics of choosing and arranging. So what is this choosing and arranging? So let's take a digression, right? So forget the Pascal's triangle, choosing and arranging. So suppose there are 10 books, right? Or okay, fine, 10 books, A, B, C, D, E, F, G, H, right? Okay, 8 books. There are 8 books, right? Of which I have to choose 3 books, right? I just want to make a grouping of 3 books, right? I want to pick 3 books. So again, there's no ordering. I just want to choose 3 books. So I can choose the first book in any one of the 8 ways. So let's say I call out C, and then C lands in my bag. And then I can call out the second book in any one of the 7 ways. So let's say I call out A lands in my bag. And then I can call out the third one in any one of the 6 ways. So let's say that happens to be E. So E also lands in my bag, right? So the collection of books I have is CAE. But is this the number of ways in which I can choose 3? No, because suppose I had called out for A first, then E, then C, then also it's the same collection. Or if I call out E first and then A and then C, it's also same. It's also same as E, C, A and all that, right? So it's saying 8 times 7 times 6. I mean that the ordering in which I call is important, when in fact it's not, right? So if I specifically say which book I call out first, so if C is going to get a gold medal, A is going to get a silver medal, and E is going to get a bronze medal, then it's a different thing, where the ordering matters. But the ordering does not matter. Therefore, I'm over counting or double counting within quotes, but excess counting, right? How much am I excess counting by? The number of times in which I can arrange A, C, and E, right? You can think of it as 1, 2, and 3. So it could be 1, 3, 2, 2, 1, 3, 2, 3, 1, 3, 1, 2, 3, 2, 1. So you can see that there are 6 ways. How are we getting the 6? It's 3 into 2 into 1, right? I can call out any one number. Let's say this is A, C, E only. I can call out any one of them first, and then any one of them second, any one of them third. Sorry, any one of them second first, any one of the remaining 2 as the second, and then the obvious last one will be the remaining one. So I have 6 ways of arranging A, C, and D between themselves. So I need to divide this answer by 6, which is nothing but 3 factorial, 3 into 2 into 1. So the number of ways for me to form a group of 3 books is this number, whatever it simplifies to 50. The 6 gets cancelled in the denominator. So it's 56 ways. So this is written as 8 choose 3. So of 8, I'm choosing 3. Sometimes people also write it as 8, 8, 3 like this. Sometimes they put 8C3. I mean, this is very rare. I haven't seen this much, but all of these are equivalent notations. Mostly the first 2 is what you'll typically see. 8 choose 3 without the letter C, you put it in brackets like this, or you explicitly say 8 choose 3. Okay. Now, so how do I generalize? Suppose I have to choose N choose R, right? it's the same thing. So suppose I have to choose n choose r. Or okay, actually let's take one other example, right? So suppose I have to choose 4 books out of 100. 100 choose 4. So same thing, 100 into 99 into 98 into 97. Upon the excess counting is going to be 4 into 3 into 2 into 1. Right? But to write it in a factorial form, factorial as we all know, so n factorial is nothing but n into n minus 1 into n minus 2 all the way to 1. That's n factorial. So to write it as a factorial form, this is not very convenient. The bottom is convenient. The bottom is indeed 4 factorial. The numerator is not in a factorial form because it ends 100, 99, 98, 97. But I can artificially make it look like a factorial by multiplying numerator and denominator by 96 factorial. By this, what happens? The numerator continues from 97 further all the way till 1. Goes all the way till 1. So the numerator becomes 100 factorial. The denominator becomes 4 factorial times 96 factorial. Right? So just for convenience, it's better to write it this way, right? In terms of just factorial rather than, for example, suppose it is 100 choose 28. Then I have to write 28 numbers in the numerator all the way from this till I think 73, right? Right, till 73.
Yeah.
And then I have to write 28 into 27 all the way. Anyway, at least the bottom I can replace it with 28 factorial. But the top, I'll have to either resort to some shortcut like putting dot, dot, dot and taking 73, right? Which becomes clumsy, right? So this is better to write it as 100 factorial by 27 factorial times 73 factorial, 28 factorial times 72 factorial. Right, so n choose r, generalizing, n choose r is n factorial upon r factorial times n minus r factorial. Okay. Now, you see a bit of symmetry in the denominator. It's r and n minus r together adding up to n. So this should be exactly same as n choose n minus r. Because if I choose n minus r, it should be n factorial by n minus r factorial times n minus r, which is back to r, right? And this is not very difficult to understand because suppose I have to choose 3, it's same as choosing 97 from a class of, okay, let's say there are a class of 100 students, right? The teacher has to select the best 97 students. The top 97 students. She's not going to say select the top 97 students. She's just going to select the worst 3 students and say automatically the remaining 97 are selected. So the act of choosing 3 automatically chooses 97 because it gets separated, right? So what you want to do with that group is a different story. The 97 will represent the school in some competition because they're the best 97. The 3 will not. But as far as the teacher's job is concerned, she had to just partition the class into 2 parts. And the moment she partitioned 3, the other 97 came out as the other partition, right? So the number of ways in which she can choose 3 is the same as the number of ways in which she can choose 97. So 100 choose 3 is same as 100 choose 97. And that's what the formula is also leading us to believe. 100 choose 3 is same as 100 choose 97. Thais, you with me? Thais, all good, right? Your voice level?
Yes,
Okay,
sir, yeah.
cool. Okay, so now specifically, so let's look at specific examples. So for example, it doesn't have to be 100. Let's say some other. So 20 choose 1 is same as 20 choose 19, which is just 20. So this, you don't need any choosing or any hi-fi stuff, right? Of 20 people, how many ways can I select one person? 20 ways. Any kindergarten kid will tell you this. 20 choose 1 is 20. 20 choose 19 is also 20 because you have to eliminate one person. So that's obvious. The other one, which is not so obvious, is 20 choose 0, which is same as 20 choose 20, which is 1. So 20 choose 20 is obvious. If there are 20 books, I'll have to select 20 books. In how many ways can I do it? Only one way. I literally have to collect all the books. But what do you mean by selecting 0 books? Of 20 books, how many ways can I make a bag of 0 books? Only one way. I'll have to take an empty bag with myself, right? The act of choosing no book is 1. So that's one way of choosing 0. So n choose 0 is same as n choose n, which is 1. And then n choose 1 is same as n choose n minus 1, which is n, right? So n choose, so the far extremes will always be 1. right? When I suppose I have to write n choose 0 here and n choose n here, the next two, first of all, the answers will be symmetric. N choose 1 and n choose n minus 1 are symmetric. This is n and this is also n. And this is what was leading us to the introduction to the Pascal's triangle. 1, n, and then ending in n1. Okay, but what is the connection between x plus y whole power 4 and this choosing business and n factorial business? So let's understand the connection, right? So for now, take it for granted that these coefficients, let's take this example, right? The block of 1, right? So this number is 4 choose 0. This number, in fact, I'll delete the 5 lines so that it's not confusing. Okay, so this number is 4 choose 0 and this number is 4 choose 4, which are both equal to 1. This number is 4 choose 1 and this number is 4 choose 3. And n choose n, or n choose 1 and n choose n minus 1 are both n. And this number is 4 choose 2. So it'll be a symmetric distribution. Now, but why is it that x plus y whole cubed or x plus y whole power 4 should have the coefficients as n choose 1, n choose 2, n choose 3? I'm talking about the coefficients here, right? Right? So let's understand that part. So suppose I'll have to do x plus y whole power 4. Okay, so what does this mean? It's x plus y times x plus y times x plus y times x plus y. Okay, suppose I'm questioning what is the, in fact, I'll take x power 5 so that it's even easier to understand, right? Not easier, but you can illustrate it better. Okay, suppose it's x plus y whole power 5. And I question myself, what is the coefficient of x cubed y square? Okay, first of all, the powers will add up to 5 always because, right, x plus y whole power 5. And you can see, right? So for example, I need to multiply something by something by something by something by something, right? So, right, this is once, because when I expand it out, you will have multiplications. Each multiplication will be a multiplication of 5 different numbers, right? In this example, I said the x here multiplies the x here, multiplies the y here, multiplies the y here, multiplies the x here. So because there are 5 multiplications, the powers of x and y will definitely add up to the same power which is here, which is 5. Now, x cubed y square, I have shown one way in which I have resulted in an x cubed y square. This x multiplied by this x, multiplied by this y, multiplied by this y, multiplied by this x, right? Another way in which I could arrive at an x cubed y square is this y multiplying this x, multiplying this x, multiplying this y, multiplying this x. There's 3x and 2 y's. Ultimately, that's what I need. I need 3 terms from which I want the x. I want 2 terms from which I need the y. So that is your 5 choose 2 or 5 choose 3. Either way, 5 choose 2 or 5 choose 3. Either I can say, of the 5 terms, give me 3 terms from which I'll pick the x, or equivalently, give me 2 terms from which I pick the y. Automatically, from the remaining terms, I'll pick the x. And since there are 5 choose 2 of them, which is 5 into 4, if I look at by 2 into 1, right? If I look at 5 choose 3, it's 5 into 4 by 2 into 1. If I look at 5 choose 3, it's same thing, 5 into 4 into 3 by 3 into 2 into 1. Effectively, these two are same. We know that these two are same, right? N choose r is same as n choose n minus r. So both are same, which is 10. So the coefficient of x cubed y square will be 10, because there are 10 different ways in which I can have multiplications where there are 3 x's and 2 y's. Okay. Hence, the coefficients here will be, if you go up here like one more, the coefficients of x plus y whole power 5 will be 1, 5, 10, 10, 5, and 1. So the specific thing that we saw was this guy, x cubed y square. So this was x power 4, y power 1. This was x power 5, y power 0. The far extreme was y power 5, x power 0. And this was x y power 4. And this was x square y cubed. Okay. X y power 4. Right. Okay. So what are we finally saying? We are summarizing by saying, if I have x plus y whole power n. Okay, so that will have lot of terms starting with x power n. Symmetrically, there'll be a y power n here. The next term will be x power n minus 1 times y. Symmetrically, there'll be a x power n minus 1 here, right? And so on, symmetrically, right? A general term here will be x power n minus r, y power r. Okay, there'll be some random term in the middle. But the thing is, we have to put coefficients for each of them. And the coefficients for each of them are what we just discovered as just n choose 0, n choose 1. So n choose 0 symmetrically here. N choose 1 is the coefficient here. N choose r is the coefficient for this general term in between, right? And I can write this using sigma notation as summation, right? Summation. N choose r. I can put the general term. That's what the summation is for, right? X power n minus r, y power r. R being my running variable, starts with 0, ends in n. If r equal to 0, that results in the first step. N choose 0, x power n minus 0, y power 0. That's your 1 times x power n times 1. And if r equal to n, so there are clearly n plus 1 terms in this. If you see, x plus y whole square had 3 terms. X plus y whole cubed had 4 terms. X plus y whole power 5 had 6 terms. So x plus y whole power n will have n plus 1 terms. And sure enough, r goes from 0 to n, counting both 0 and n, that's n plus 1 terms. So if r equal to n, the last term is, so I should write this as, sorry, not a mistake, but I should write this as n choose n minus 1, which numerically is same as n choose 1. Numerically, it's same as this. And similarly, this is n choose n. Numerically, it's same as n choose 0, which is 1. These two are same, right? Okay, all right. So, so typically, someone might ask, what is the coefficient of, suppose I have 2x minus, okay, all right, let me not put x here. I'll just say 2a minus 3 by b whole power, actually I'll say 1 by 3b. 2a minus 1 by 3b whole power 100. Okay, and suppose someone asks me, there is a term which has a power 63, right? And the question is, what will the power of b be? And what will the coefficient here be, right? I'll just say k. Okay, so I'll just say, I'll write it as b power some m, right? So the question is, we'll do it together. So find k, find m. Suppose these are the two things we have to find out. Okay, so the first thing is easy. We just saw that the power of, so when I expand this out, I'll have a power something, right? And 1 by b power something, right? And these two powers should add up to 100. We know that. These two powers should add up to 100. We know that, right? So in this case, if it's a power 63, then it must be 1 by b power the balance, which is 37, right? Because the two powers will add up to 100. And therefore, my m is therefore minus 37. So we know that this is a power 63, b power minus 37, or rather 1 by b power 37. But to answer in the specific question, it's b power minus 37. So 63 and 37 add up to 100. Okay, now what about k? So k should be, so what will that term will be 100 choose 37, right? 2a power 63, which is 100 minus 37, 100 minus 37, yeah. And then minus 1 by 3b whole power 37. right? So if I look at this, a power 63 is here, b power minus 37 is here. The rest are numbers. What are the numbers? We have 100 choose 37. And then we have 2 power 63. And then we have 1 by 3 power 37. And then we have a negative signage because it's negative 1 power 37. Therefore, have a negative sign in front of it. So my k is the combination of all of these numericals. It's a negative number, which is 100 choose 37 times 2 power 63 upon 3 power 37. That is my k. Does this make sense, guys? Okay. I did a little more difficult problem to start off with. Obviously, there'll be easier problems that you guys can get warmed up with. But if you are able to understand this, the other problems should be fairly easy. Okay. All right. Let's stop here. We'll continue on binomial theorem. We'll go on to permutation combination next class. I'll assign homework on both exponents, logarithms, and binomial. Okay. See you next class. Bye.
Thank you, sir.
Thank you.